Jakiva King.
Are you ready?
All right, this is at THS Mr. Jones, and we're going to talk about chapter 4.3 today. And 4.3 is talking about dividing polynomials. Okay, so this was the only operation that we haven't talked about yet. We've done adding, subtracting, and multiplying, but we haven't really got into dividing the polynomials. Okay, before we go into polynomials, I want to review how to divide numbers. Okay, so let's say we have, we're going to do long division and synthetic division. So let's say we have the number 6,542, and we want to divide that number by, let's say, 21. Okay, so you'll set it up like this, and you'll think, okay, 21 goes into 6 how many times? None. And then 21 goes into 65 how many times? 3 will be the closest, and you'll get 63. So you'll take this number here times this out here, put it here, and then we subtract. So then 6 minus 6 is 0, 5 minus 3 is 2. So you had 2 left over. You bring down your next term, which is a 4. And then you say 21 goes into 24. How many times? It's 1. So you take 1 times your 21, and you get 21. Subtract, and you get 3. Bring down your next term is a 2. Okay, and then 21 goes into 32. How many times? It is once, and you get 21. You subtract, you get 11. Now, since we have no more terms to bring down, we could put a decimal and put some zeros, okay? But since we're going into polynomial division, we want to leave this remainder, okay? And how we would finish this is we would say this is 311, and I had 11 items left out of 21. Okay, so we would write this as a fraction, and then this here would be our answer. So this is the exact same process that we will use when we do polynomial division. For example, if I take x squared plus 4x minus 5, and if I divide that by x minus 1. Okay, I have to have every term accounted for. So if I didn't have an x in here, I would have to put a 0x. Okay, same thing out here. Now, when we do this division, we're trying to line up, or we're trying to match up our first terms. So we're thinking, how can I make an x become an x squared? Well, all I have to do is multiply by x. So I'm going to line it up with the x. Then we will take this term on top times both of these. Okay, so x times x is x squared. X times negative 1 is negative x. Then the next thing we did was subtract. Okay, so these cancel, and you have 4 minus negative 1, which is 5x. Bring down your next term, negative 5. Okay, and then again, you're trying to match this first term with this term. So how do I make an x become a 5x? Well, I multiply by a positive 5, then take the positive 5 times both of the terms out front. So you get 5x minus 5, subtract, you get a 0. Okay, so you have no remainders. Now, basically what this says is that x squared plus 4x minus 5 is the same thing as x plus 5 times x minus 1. Okay, we're basically factoring it, but we're checking with division. Okay, we had what's called long division, or so this is long division. We have what's called synthetic division, and it works. It does the same thing, just in a different process. So I'm going to use this same problem right here. So with synthetic division, we're going to take only the coefficients of our polynomial. So we're going to say 1, 4, minus 5. And we're going to set up our division upside down. Okay. Out here, we're going to use this right here. But instead of having the factor, I want the 0 out here. Okay, so if x minus 1 is a factor, x equals 1 is my 0. Okay, now this process is usually really quick, but it doesn't work for everything. It will only work if it's a binomial out here, okay, of degree 1. So the first thing we're going to do is we're going to take this first term and bring it straight down here. So that is a 1. Okay, then we're going to take our 0 times this number and put it right here. So 1 times 1 is 1. Then we will add going down. Okay, so 4 plus 1 is 1. Then we multiply. Oh, that's a 5. Then we multiply. 1 times 5 is 5. And then we add and we get 0. This last item here is your remainder. Okay, so you have your remainder. Then you move back. This is your constant term. Move back. This is x. If I had more numbers, I'd go x squared, x to the third, x to the fourth. So what this is saying is that x squared plus 4x minus 5 is x plus 5 from right here times x minus 1 from right here. Okay, and we get the same answer. So this synthetic division will be very quick when we're just checking to see if items are zeros or not. You can do it the same way on both. Okay, and that's all 4.3 is just practicing these two methods of division. Okay, so we've got some questions here. So question 1 is how do I want to word this? If I divide 8x4 minus 5x to the third plus 7x minus 2 by 2x squared plus 1. Okay, your question is, what method do I have to use? And what is something special I have to do? Okay, I talked just briefly about something special you have to do if things are missing. So what do I have to do special with this one? Okay, so maybe just set this problem up. Don't do it unless you really want to, but set it up and see what method you're going to use and what special thing you're going to have to do. And question 2 is, why is synthetic division better than long division? Okay, why is synthetic division better than long division? Okay, and then your suggested problems start on page 416, and they are numbers 5, 11, 21, 23, 33, 43, 47, 55, 59, 61. And let's go with true or false, which is 69 through 72. Okay, so try to make this one really short. It's just it's all division. So we just have a lot of practice problems on dividing polynomials. Okay, This is at THS Mr. Jones. If you have any questions, please let me know.